Hello and welcome. Imagine a world where all the continents are fused together into a single enormous landmass. A place where oceans shrink to narrow edges, deserts stretch for thousands of kilometers, and forests cling to the coasts. Today, we're diving into an extraordinary what-if. Pangea never broke apart. Millions of years ago, the Earth looked completely different. A single massive landmass called Pangea stretched across the planet. Then, about 175 million years ago, it broke apart into the continents we know today. But imagine if that had never happened. What would the Earth look like if Pangea remained whole? The first thing to notice is scale. Pangea would stretch thousands of kilometers in every direction, forming one colossal supercontinent. The seas that today separate the continents would shrink, limited to narrow margins along the edges of the land. Vast interior regions would be far from the moderating influence of the ocean. Rainfall could not travel deep into the heart of the continent, leaving enormous deserts in the center, while lush rainforests would cling to the coasts and river valleys. North America would lie close to Europe, stretching from the western edge of Pangea to the eastern. Asia would rise to the north, near what is now Russia, while Antarctica would remain at the southern tip. India and Australia would sit further south, connected to the frozen expanse of Antarctica. Regions that once enjoyed warm climates might now be buried under ice and snow, while the vast interior deserts would bake under the sun. Climate across Pangea would be extreme. Coastal regions bathed in ocean winds would see abundant rainfall, creating dense forests and sprawling wetlands. Inland areas would bake under the sun, forming deserts that stretch for thousands of kilometers. Rivers would carve dramatic valleys, creating life-giving oases in the otherwise arid interior. Storms would rage along the coastlines, driven by the contrast between ocean and land temperatures. Winds would sweep across plains and mountains with unprecedented force, shaping the terrain over millennia. The mountains of Pangea would rise higher and more frequently than on the modern Earth, with tectonic plates locked together in a single supercontinent. Collisions would be constant, forcing ranges to tower across the land. Volcanoes would erupt with dramatic regularity, spewing ash and lava across the surface. Earthquakes would reshape valleys, create new rivers, and fracture plains. The land itself would be alive with movement, constantly changing under immense geological pressure. Oceans along the edges of Pangea would shrink, creating confined seas that teem with unique marine life. Currents that once circulated across the world's oceans would slow, isolating regions and creating zones of scarcity and abundance. Some areas would become rich with nutrients, while others would struggle to sustain life. Marine ecosystems would evolve under these new pressures, forming entirely different species than those seen in today's seas. The interior deserts, stretching thousands of kilometers, would challenge all life within them. Sandstorms could sweep across plains for days, driven by hot winds rising from sun-baked rock. Temperatures would swing wildly between day and night, scorching during the sun's peak and freezing under the clear night sky. Only the most adaptable plants and animals could survive in these harsh conditions, evolving strategies to store water, hide from predators, or escape the relentless heat. Meanwhile, the rainforests along Pangea's edges would be lush and vibrant. Towering trees would dominate the landscape, their roots entwined with rivers and wetlands. Countless species of plants and animals would thrive in these humid regions, creating a complex web of life. Massive rivers would flow from mountain ranges to the sea, carving valleys and nourishing ecosystems along their banks. Wildlife would adapt to constant rainfall, dense vegetation, and the competition of crowded habitats. Deserts, forests, and mountains would all exist side by side, creating a planet of extremes. Some regions would be covered in snow for much of the year, while others would scorch under an unrelenting sun. Winds would race across plains, tornadoes could form along desert margins, and monsoon-like storms would sweep across the coastal forests. Climate variation would be unlike anything known today, as a single landmass amplified extremes rather than moderating them. Travel across Pangea would reveal astonishing contrasts. Coastal wetlands could give way to deserts within a few hundred kilometers. Mountain ranges would rise dramatically, forming natural barriers, while massive river valleys would carve fertile paths across otherwise barren regions. Wildlife would migrate across vast distances, following water sources and seasonal vegetation. Adapting to the extreme diversity of habitats within a single supercontinent, the sheer size of Pangea would also affect atmospheric conditions. Large deserts would increase dust in the air, creating hazy skies and altering sunlight. Winds would carry heat across long distances, making storms more intense. Extreme temperature gradients would generate violent weather patterns, with hurricanes and cyclones forming along the coasts and spreading inland. Life across the land and seas would evolve in remarkable ways. Species that rely on water would cluster near rivers, lakes, and coasts, while desert-adapted animals would roam vast open spaces. Predators would travel long distances to find prey, while prey species would develop strategies to evade capture across enormous, unforgiving landscapes. Ocean creatures would adapt to narrow seas, forming ecosystems completely different from today's oceans. Volcanoes and tectonic activity would continually reshape Pangea. Mountains would rise and erode, rivers would be diverted, and valleys would collapse. The land would never stay the same for long, forcing species to constantly adapt or face extinction. Life would evolve under relentless pressure, sculpted by an environment far harsher and more extreme than the modern Earth. Despite the challenges, Pangea would also have immense beauty. Towering mountain peaks, deep valleys, expansive deserts, and vibrant forests would dominate the landscape. Seasonal changes would create dramatic contrasts with snow-capped mountains next to sun-scorched plains, and storm-lashed coasts beside calm inland lakes. The planet would be alive with movement, color, and energy. If Pangea had never broken apart, the Earth would be a planet of extremes. Oceans would shrink, climates would intensify, species diversity would be limited, and landscapes would constantly shift under tectonic forces. Life would survive, adapt, and evolve under some of the most challenging conditions imaginable. The eventual breakup of Pangea allowed the modern Earth to exist as it does, with separated continents, varying climates, and diverse ecosystems. But imagining a world where the supercontinent remained whole gives a glimpse into a planet both alien and awe-inspiring, a place where nature's power stretches across mountains, deserts, oceans, and skies in ways beyond imagination. Millions of years of geological activity, extreme weather, and environmental adaptation would shape a world unlike anything we know today. Pangea would be a land of contrasts, where survival is a constant struggle. Beauty is found in extremes, and life must adapt to a planet of colossal scale. Even in the briefest glance, a single, unbroken supercontinent reminds us of the immense forces shaping Earth. Mountains rise, rivers carve valleys, deserts stretch endlessly, and oceans cling to the edges. Pangea would be a world both breathtaking and brutal, a planet where life is tested, sculpted, and defined by the raw power of nature. This is the story of a planet that never split, a supercontinent frozen in time, and a glimpse into the extraordinary, awe-inspiring possibilities of a world shaped by one massive landmass.